So like we have discussed the serial peripheral devices, now we have to discuss UART. Okay, the UART is also a serial standard for communication between the MCU, our microcontroller unit, and between our MCU and our device. Fine. So let's understand UART in detail. So if you see here, what is UART in one line? UART is a way for two devices to talk to each other using just two wires, no clock needed. Here you have to understand there is no clock, it is not synchronous, there is no clock. Okay, so here if you see UART is a way for these two devices to talk to each other using two wires. So the two devices would talk to each other how? Using two wires. Okay, so there is also no clock in between them. Okay, then the next thing that you have to understand that is about SPI. Here in SPI we have said that there are three wires, there is a clock, one controller, that is microcontroller unit is the, and one peripheral is the, then it is synchronous. This is what we have discussed in SPI. In UART there is two wires, there is no clock. There are two devices actually, both can send and receive, and these are asynchronous. It is not synchronous because there is no clock. Okay, now let's see why there is no clock. With CPI we have said the SCK clock wire is the which tells both devices now you can read the bit, right? When you can read the bit and all. So they are like both these devices are in a sync. But with UART you have understood that there is no clock. So how do they stay in sync? How does the two devices stay in sync? In UART both devices agree on the speed before talking. Hey, let's both talk at 9600 bits per second. Okay, agreed. Now both send or receive at exactly the speed. No clock needed because speed is pre-agreed. This pre-agreed speed is known as the bound rate. So here what happens in UART, both devices before doing the send or receiving thing part, they will agree on speed. They will tell each other let's talk at this speed, like for example 9600 bits per second, and they will agree on the speed. The speed that is the pre-agreed speed, the speed that they agreed before they are doing the send or receive part, that is why they are called as pre-agreed speed. Now there is a name for this pre-agreed speed, that is known as the baud rate. Okay, so baud rate is the number of bits which is sent per second. The common baud rate is 9600, or you can see here 1,15,200 bits per second, which is most fast commonly. These are the common baud rates. Okay, both devices must use the same baud rate. That is the main rule here. One device using 9600, one using 1,15,200 bits is wrong. Bits per second, BPS, that's bits per second is unit, you can see here. Both of them, the main rule of baud rate is that both these devices should agree on the same baud rate. And the common baud rate is 9600 and 1,15,200 is the common baud rates. Okay, now this 9600 is slow and reliable, and 1,15,200 is a fast commonly used baud rate. Fine. So like two people talking, if both speaking English only we can understand. If one is speaking English and one is speaking French, means we cannot understand, right? The same thing is happening here. Both of them should speak, both the device should speak at the same speed. Bits per second, BPS should be same in both the devices. That is the main rule of baud rate. Okay, now I told there are two wires in UART. The first is the TX wire and next is the RX wire. TX wire means if this device A has this TX wire, means device A is sending data to device B. So at that time device B would have RX wire because it is receiving that. This is sending, transmitting that data, and it is who is receiving would be having this RX. It's known as like RS, receive, gets the data. Now another wire is here. Another wire is that one would be from, now if this device B is sending data to device A, device B will have this pin, TX pin, transmit pin, because it is sending the data, and since device A is receiving the data, it would have what, the RX pin, receiving pin. Understood? So there are two wires like that, one to transmit the data from device A to device B, and the other to transmit the data between device B to device A. Now, so there are two pin we have understood. The transmit pin is also there, and also what pin is there, then also the other pin which is there here is the RX pin, that is the receive pin. Understood? We have the transmit pin as well as we have the receive pin here. Fine. Now if you see TX of a device A connects to the RS of device B, that's the rule, and RS of device A would be connected to other TX, that is TX of device B connects to the RX of device A, like that. TX should always connect to an RX. TX to TX and RX to RX is not possible. TX should connect to the TX should connect to an RX always. Fine. Now this is asynchronous. SPI we told you it was synchronous. It is asynchronous. It's not like we have to understand, like it's not based on the clock, right? It is tick bit is the clock guiding the SPI, but UART all the bits are going and there is a timing guide is there. No clock is guiding, a timing is there here. That is why they have agreed upon a bond rate, right? So how, let's see how this UART would send data. The UART is sending data in packets. UART doesn't throw bits randomly. It wraps the data in packets with start and stop signal. There is a start bit and there is a stop bit. So in one UART, the data packets, the 8 data bits would be there. In start bit also is the stop bit is also there, and sometimes a parity bit can also be there. Then the 8 data bits. This is how, like packet, one UART means one data packet would be sending like this. So it wraps this data in a packet with a start bit which would be having 0 value, and stop bit would be having 1 value, and optional parity bit would also be there. And 8 bit, if you want to write, if I wanted to send 8 data bits, then 8 bit data bits would also be there. Fine. So this is how UART would send data. They will send data in what? They will send data in packets. This much we have understood. Now if you see, the next thing that we are going to understand here would be that is, we told you that how the data is transferred in packets. The packets contains the 8 data bit also. 8 along with this actual data, it has the start bit which will be always 0. Wire is normally high. The start bit pulls it low, 0. Wire would always be high. So in order to understand, the start bit will pull it to the 0. This tells the receiver, hey, data is coming. That is what the start bit do. It tells the receiver that data is coming. Now there is a parity bit which is optional. That is, a parity bit is an error checking bit. Helps detect if data got corrected in some data and will change. Right, did you receive exactly what I sent is usually checked. It's an optional part, but it is used for correcting, checking if the same data that we have sent is received there. If the data get corrupted in between, that is checked using this parity bit. Stop bit, that's the end of the data. Like over and out we will say in walkie-talkie, like that. So its wire goes back to high now. So wire was initially, the wire would be always, that is the TX wire. We are talking about this TX RX wire. So when we are transmitting a data to RX, we will be transmitting one packet to this RX, that is the RX side, device B. So this wire would be initially high. So first we have to start we are telling the receiver the data is coming. So you have to pull it to low. That is why we have the start bit low, which tells the device that the data is coming. That is, tells device B the data is coming. Then we have this 8 data bits. 8 bits of data would be the actual data which is sent. Now we have parity bit. Parity bit is like an optional bit. It actually used to check if whatever we have sent, the same thing has come in the device B side. Then to stop that it is finished, the data is, end of the data has reached the receiver side, then we have to put this wire back to high 1. That is why the stop bit is always 1. So this is how each part you have to understand. So let's see the full UART communication, how it is happening, the full UART. That is, A wants to send letter A to device B. Let's say letter A in binary, it will write, both would agree on a bound rate. Let's say 9600. But first thing is what? Both would agree on a bound rate. Now device A would send the package to the device B. So first the start bit would be 0. Actual data, stop bit would be the ideal 1. Now device B sees the start bit, okay, data is coming. Now reads 8 bit at agreed bound rate timing. It will read each of these 8 bits at the same bound rate timing only it will read. Sees the stop, that is data is completed, so it will get the letter A, reconstruct it and get the letter. So it will read also, send the data in the same bound rate, it will read the data also in the same bound rate. Understood? At the same bound rate itself, data reading and data writing is basically happening. Fine. So this is the difference. There is like two device asynchronous equal partners, not like one controller and one many peripherals, not like that. In SPI it was like one controller and many peripherals, but here equal partners are there, two devices. Fine. And start or stop bits is not there. Here if you see, the common use in SPI is SD card display sensors and all, but UART is between like Bluetooth connection, PC communication, Arduino debug, GPS. These are the places where UART is used. You have to learn the common uses of where we are commonly using SPI and where we are commonly using UART. You can see UART is used in GPS, Bluetooth communication, PC communication, Arduino debugging and all, which is basically Bluetooth, GPS, PC communication, Arduino debugging and all is mainly used. These are the real examples in which the UART is mainly used. That is, if we see GPS and location data view UART, that is to TX to REDV would receive that location data through UART, TX to REDV, that our board it will send. Bluetooth, we know, uses UART to talk to, that is HC05 Bluetooth module uses UART talk to MCU. Now UART is sending text to our laptop. UART, that is serial.print. Arduino debugging is this. UART can send text to laptop. So in GPS we are sending our data location to REDV. So in the receiver side we have this REDV. Now Bluetooth, you can see we are sending, uses this UART to talk to microcontroller unit. Arduino is like if you wanted to send some, if serial.print is hello, that is one Arduino code. Let's see, now I am sending that to my laptop. So this text I am sending to laptop, that is through what? UART. I can send that. So these are the real world example. Now display sensors, SD cards and all are the example of SPI. Fine. SPI's example is like when you and also from the REDV also to the laptop, if you see the code, whatever which was there in our REDV code, we see it in the laptop, then that is also a UART communication. Fine. So this real world example you have to know. Okay. So GPS is from UART to REDV. Bluetooth is through UART. You can send it to our MCU, microcontroller unit, and Arduino is like to the laptop. Okay, fine. Now this is just a summary, it's just summary, that's it. Okay, now let's understand how the complete working. We have already understand the complete working. Here if you see, this was my notes, KTU notes here. This you can download directly from here. You can see the working. This working we are going to understand right now. So there is this sorry, we have gone a little back. Okay, there is this working, different steps. These steps we are going to understand here. So let's understand this working. Basically here each working I will teach you. So first let's understand. First we have the working, so maybe I can discuss the working in the next part. Maybe this is 15 minutes here. If you see, this is 50 minutes. I will now discuss the working of UART in detail in the next part. Thank you.